Hi everybody, today we're going to talk about effective interest rates. So let's start by answering this question. How much money will you have in 4 years if you invest $87,000 at 4.8% compounded, A, quarterly, B, monthly, C, weekly, or D, daily? And for daily, let's be clear that we'll use 365 for days in a year. We are going to have to use the formula A equals P times 1 plus R over N to the NT. This will let us see our future balance for our investment. To find our quarterly balance, we'll do A equals 87,000 times 1 plus 0.048 over 4 to the 4 times 4. To get monthly, we'll do A equals 87,000 times 1 plus 0.048 over 12 to the 4 times 12. For weekly, we'll do A is 87,000 times 1 plus 0.048 over 52 to the 4 times 52. For daily, we'll have A is 87,000 times 1 plus 0.048 over 365 to the 4 times 365. In each of the cases, you'll see the major difference is dividing the interest rate by the number of compoundings and then using the number of compoundings in the exponent as well. Let's take a quick look at putting this in a calculator. So I type in 87,000. Make sure you use the parenthesis 1 plus 0.048 divided by 4. Go outside of the fraction to close the parenthesis. Then I use my exponent. You may need to put parentheses around the 4 times 4 to make sure that both of those numbers stay in the exponent. We see our future value is $105,294.93. Repeating the process, we'll find that using monthly compoundings, we'll have $105,374.97. Weekly compoundings gives us a future value of $105,406. And then daily gives us a future value of $105,414. What we see here is that more compoundings equals more money. The more often we compound, the more money we receive. This also shows us that the compoundings increase the amount of interest. Compound interest earns a slightly higher interest rate than the amount stated. To see the true interest rate being earned on an investment, we can calculate the equivalent interest rate that would be earned if the interest was paid annually. We call this calculation the effective annual rate. The effective annual rate, denoted R sub E, can be found using the equation R sub E is equal to 1 plus R over N to the N minus 1. Stop and look at this equation for a minute. There are some things that are missing that we usually include in our financial calculations. Number 1, notice that we didn't include the principal. This means that it doesn't matter how much we invest, the effective interest rate is the same for all investment. Notice we're also not including the time. We're only looking at the interest rate and how often we compound it. A quick note about terminology. The effective annual interest rate goes by a variety of names. We may call it effective rate for short. Some people might call it effective yield, while other people might call it an annual yield, but they all mean the same thing. You might also see an EY or an AY as a notation. So let's try a few examples. Let's find the effective interest rate for an investment earning 8.6% interest compounded monthly. Here our R is 0.086 and our N is 12. Our formula, R sub E, is equal to 1 plus 0.086 over 12 to the 12 minus 1. In the calculator, we put 1 plus 0.086 divided by 12, go outside the parentheses, close the parenthesis, exponent of 12, then make sure you get outside of the exponent before you subtract 1. This says we have 0.08947. As you're computing effective annual interest rates, you want to use a lot of decimal places. Let's say 4 or 5 at a minimum. So our RE is 0.08947, which we can write as 8.947%. We can see it's slightly higher than the stated rate of 8.6. Our next example says a bank offers 2.4% interest compounded quarterly. How much money will you have if you invest $5,400 for 8 years? What is the APY? In this example, R is 0.024, N is 4, our principal is $5,400, and our time is 8. To find our future value, we take $5,400 times 1 plus 0.024 over 4 to the 4 times 8. This gives us a future value of $6,539.27. To find the APY, which we know is the same as the effective annual rate, we calculate R sub E is equal to 1 plus 0.024 over 4 to the 4 minus 1. This gives us RE is 0.02422, which would be 2.422%. Again, we can see that slight increase in the interest rate based on the quarterly compoundings. Our last question says Bank A offers a savings account with 1.2% interest compounded daily. Bank B offers a savings account with 1.25% interest compounded monthly. Which option is better? When banks have the same compounded period, we can easily just take the bank with the higher interest rate. Because the banks have different compounding periods, we need to convert this to the effective annual rate to equally compare the interest. For Bank A, the effective rate is 1 plus 0.012 over 365 to the 365 minus 1. This gives us 0.01207. Let's do the same thing for Bank B. This time, our RE is equal to 1 plus 0.0125 over 12 to the 12 minus 1. This gives us 0.01272. Comparing the two rates, we can see that Bank B is better.